Yep, that's great. We can see your screen. And can you unmute your mic, please? Can you unmute your
okay,
mic?
yes. Can you hear me?
Yeah. Yeah,
okay,
go
great.
ahead, please. Thank you. Forum is yours.
Okay, good morning, everyone. My name is Zhaozhen. I'm from University of Bristol. So today I'm gonna present my research about the analysis of open domain question corpus. So, so this is like a brief context about what I'm gonna talk about today. So I'm gonna start discussing about like the background and the motivation about this research, and then we will talk about how we collect the data and how we pre-process the data. Then we identify like several different tasks for the question analysis. So we're also going to introduce that. Then we have a generalist model, which we name it called QBERT. So it's like a question specific version of the BERT to analyze the corpus. And then I will explain the experiments we did and the result we had. And then we're going to apply this QBERT, the model, to the new corpus we collect and show some analysis about the corpus. So, according to like a US report on the smart speakers consumer adoption, they show that like at 84% of the user had tried to ask a question through the speaker, and 36.9% of them asking the question on a daily basis, and 66% of them asking on a monthly basis. So with these reports, we can see that like every day we have like numerous like new question coming up. So we come up the question like, how are we going to analyze this question, because they are just, you know, like probably like one single sentence question and without any label, without any other useful data. But how are we going to analyze it through the context itself? Then in the 2017, so a local museum in Bristol in UK, it's called With the Curious. So it's like a science sentence. It started the intention of holding an exhibition about the curiosity of the city. So to hold this experience, they start to collecting questions around the Bristolians about like what they are curious about. So there are no given context like what question you can ask, what you cannot ask. So they just try to collect from their visitor and from the citizen in Bristol about the question of their curiosity. So more than like 10,000 questions were collected initially, and all questions are like unlabeled. So here is like a word cloud of this, of all their question they collect. So we can see it's like contains many different topics. So it could be like related to space, related to the Earth, and also like related to dinosaur, about life, about time. So it's like a question, like an open domain question data set that contains different topics. So how do we collect the data? So the data was collected by the science center, sorry. So it's collected between January 2017 to October 2020, and the question is mainly collected from 3 different aspect places. Like, so for on-site is like the when the visitor visit the venue, they write their question on their card, and they later this question on the card was enter and store manually by the by the Science Museum. So then another main resources of the questions offsite. So the offsite question is that like the museum holds several like offsite events around Bristol. So some of the general submission are from the visitor going to that offsite event. And another way is through online. So the user can just entering their questions through the With the Curious website. And the museum, the people from the museum also like they do some moderation about the data. So the question was first moderated manually by With the Curious staff. The question in the database was also screened for any possible identifying information or like potential offensive or inappropriate language or content. So these kind of questions were removed from the database. So also the raw data corpus, when it comes to us, it's also including many like repeated questions, and it's like come from different types and topic, and some of them are even like just non-question sentence. So we did some, rough preprocessing before we start to analyze the corpus. So such as we removing the exactly identical questions and the questions that are shorter than 3 words. So after these steps, the filter WTC datasets contain like 8,600 questions, and which has 5,700 unique words. And the length of the question is like between 3 to 55 words. And yeah, and 87% of the question are within 10 words. So it's like basically like short sentence. So to analyze the question, we identified like 3 different tasks. So the first task is question topic classification, which is like when you give it questions, the model labels the topic of the question, and the questions were categorized into 10 different topics. And the second one is equivalent question recognition. So in this task, the model is aimed at like classifying if the question pairs given to the model are similar or not. And based on that, the model is expected to group similar question in the vector space. And the third task is question answering. So it's like giving a question, and the model is try to look at through a knowledge base and to find like a 1-sentence answer for the given questions. So we determined this task is an open domain, open book question answering, because our question has no limitation in domains, and the model allows to answer the question with the content provided. So this is our like our model. So our model is based on a sentence embedding model called as sentence BERT. So so for the model, we take like an input sequence pair, and it's in the sequence pair is embedded with BERT. So BERT, then it's the after the embedding. So there is like apply a mean pooling strategy. So which is take the output, calculate the mean of the output tokens from BERT as the embedding of the sentence. So comparing to the traditional way, comparing to the way BERT calculate the embedding, they always take a token called CLK token. So they take this as an embedding, but here we calculate the mean of the output token from the BERT. Then we got the embedding, and we apply some task-specific loss function for each for different tasks. And So for the classification task, for most of the classification tasks, we use the, while we train it, we calculate the online contrastive loss. And here we can say the D here in this equation is the cosine distance. So we try to, so when, and Y is the binary label. So when Y is 1, so which means like 2 input sequence are related and the embedding are similar to each other, the distance, we minimize the cosine distance between these 2 embedding. Then so we try to, so when the label is 0, which means that the 2 embeddings are not related, we try to increase the distance between embeddings and until it's more than the margin we are given. So the margin ensures that the negative samples has a more significant distance than the margin value, and the online contrastive loss only computes the loss between hard positive and hard negative pairs. So during the training, because we have this, we calculate the loss and match the loss from, with the label, but during the inference period, then we only calculate the cosine similarity distance between 2 embedding. So in this case, to match the distance to the label we need for question topic classification, or like equivalent question, or even the question answering, then we need a distance threshold. So during training, we find the different threshold for each task. So when we during the inference, then we just find, so for given sequence pair, if their distance is, let's say, large, is smaller than the given distance threshold, then we are considered as like related to each other. So this is one of the thing about the QBERT is that we train this we try to make QBERT like a generalist. So it's not only gonna work on one task. We try to train it for to deal with like all 3 tasks together with one set model. But one thing we find is that, so for question equivalent tasks or question answering tasks, because the model can take 2, like a pair of input, but for question topic classification, usually we only need 1 question, and it's like the model gonna return 1 topic. So in this case, we actually only use like a simplified version, so which is only content one BERT in our model. So yeah, so the question topic classification only take 1 input, and we use the softmax function to produce the topic of the questions. And then, so we train our QBERT, we train the model on 4 different data sets. So one is the QQP, which is the Quora question pairs, which it's come up with similar question pairs. And another one is WikiQA. It's a question answering data set that come with question and the candidate, 1 sentence candidate answer. And for here, like YT and YQA are 2 data sets that we generated from the from Yahoo Answer. So Yahoo Answer, it has like the question, then it has a context of the answer, and also the editor will label like the topic of the question. So YT is we only have the question and the topic part, and YQA is only have the question and the candidate answer part. So while training our model, so we're following the pre-training of BERT and SBERT. So BERT is pre-trained with 2 unsupervised tasks, mass language model and next sentence prediction. and XBERT is trained with natural language inference data set and semantic textual similarity data set that contain sentence pairs with label. So XBERT is like trained to capture the sentence similarity. But based on that, we we train the model on these four extra data sets we mentioned before. Yes, so here's some training, some details of the hyperparameter. So we train it for different data sets. We train with different epochs and batch size, and we optimize them with Adam optimizer. And during the training, we also need to find the distance threshold I mentioned before, based on the best accuracy from the training set. So here are some results from our experiment. So the first one, the STS plus NL1, this one is the original XBERT model. We use it kind of like our best baseline. It didn't fine tune on any question related data set. So the rest of them it's fine tune with the data set question related data sets. So for example, for the difference between this QP plus WikiQA plus YQA means the order of the data set we're training. So during the training, we find out that the training order of the data set is matter to the result. So as you can see here, if we train the data set with if we train the model started from the QE task, then it goes to other tasks, then the performance on the so the performance will be better for the question answering comparing to the question equivalent classification. So if we put the question equivalent task at the end, then the performance will be the question equivalent task performance will outperform the other task. So however, for QT, because all the QT models is trained with the different structure, so it's fine-tuned. So it's fine-tuned based on the QE and QA model. So QT task does not require the embedding model to capture the sentence similarity. So therefore, even when you add more semantic textual similarity data set, does not significantly affect the result of the QT. But when you look at QE and QA, if you add more data, so for example here, if the QQP is only we only train the model on the Quora question pair data sets, then it's performed better than the expert who haven't trained on any question related data set. But when we add more data, add more question answering related data to the model, then it's has the best performance among all these different models. And here we can see in the question answering classification task, actually here it's the expert actually seems to have the best performance. That's because that the WikiQA dataset itself is quite biased. So it's actually so when we check the results of the prediction, then we can see actually this model is just labeled all the data to zero. So so here the 95.24% of the accuracy is actually the percentage of the negative samples in the data set. So to analyze to use this model to analyze the corpus, the with the curate's corpus, we try to find we use this highlight model, which has like a more balanced performance on all the tasks. So yeah, so it's, even though it's not the best, like it didn't reach the best performance for QE or QA, but they're relatively like having a balanced performance among all these models. Then here's like some analyze about the new corpus. So for the with the curate's corpus, so we first do a question topic classification, and apart from topic classification, we also classify the type of the question. So for the types, it's like basically we put it into like WH question, like what, where, and why, this kind of thing, and also how and if. And for the type classification, we just use keyword matching. And for the topic, so it's like we have like 10 different topics. So this is according to Yahoo Answer, like what kind of topic they're given to the question. So here is some of the samples from the with the QBERT data set. So by predict the topic for and the type for the question, we have this contingency table. So we can see the most asked topic in the corpus are like science and mathematics and the society and culture. So these two categories made up like 66% of the corpus, and more than half of the questions are like how question and why question. So by navigating the if question, we observe that most of the questions are counterfactors, such as like what if we never went to sleep, or something like if you could hear in space, how loud would the sun be? So however, the corpus also contains a number of like factual questions, as would be expected in a science sentence. So for example, like some factual question will be like, I would like to know if atoms are made up of other atoms, something like this. And we also calculate we also try to understand the association between type and topic by calculating the probability. So we find out that who is like type who is strongly associated with education and the reference, and also with sport. And the type F is like strongly associated with politics and government, but not with education and reference. Then we look at we start to detect the equivalent questions. So by detecting equivalent question, we actually sample like 1,000 questions and generate a list of candidates of the question pairs. So here is the sample of the data we label. So we can, but when we label the data, if we consider that if the two questions has the similar answer, then they are similar. If they don't have, they cannot be answered by the same answer, then they are different. So QBERT managed to obtain 90% of accuracy on the sampling data. So by applying QBERT, actually we managed to cluster the questions. So we build a graph with the question node using the cosine distance matrix. So an edges is added to the node if the distance between a pair of questions is smaller than the threshold. So we find out like more than 6,000 communities, which represents 6,000 different questions in the corpus. And of these, like 5,400 of the questions do not have any similar question in the corpus. So then we're going to the question answering part. So here we try to find some question that can answer with high confidence. So we, when we answer the question, we look up from the Wikipedia summary. So Wikipedia summary is like basically the title and the first paragraph of the Wikipedia article. So we're using the distance threshold to identify which of the candidate sentence among this like 22 million sentence can be the answer of the question. Then when we perform the searching for this for the answers, we're using like approximate nearest neighbor search, which trade off some of the accuracy, but it's like for the speed. So here is the result of like how many the question can we find out that like over 2,000 questions in the with the curious corpus can be answered by QBERT and the Wikipedia summary. So WH questions such as like which and what and how and where and who are more likely to be answered by Wikipedia summary comparing to F question and the yes/no questions. So due to QBERT's mechanism, the answer is supposed to be one sentence from Wikipedia. So in this case, factual questions, which can be answered with fact expressed in a short sentence, are more likely to be answered. So more than 50% of the educational and the reference question can be answered. Also, science and mathematics questions are more likely to be answered with high confidence. However, BERT can only answer like 17% of the questions in politics and government. So here's some like samples of the question and answer we can see that generate from BERT. So we can see here, like we find out some of the problem here is like is, for example, like when in the question 1, the retrieved answer is adapted to a specific attribute rather than like a general situation as human understanding. For example, here it's asked the oldest tree in the world, but the answer QBERT given is like only within Northern Europe. So another thing we find is that some of the questions, so for here, for question 3, the original summaries is actually say like the Zygonis is a genus of dragonflies and they lay eggs into wet dangling root of the plant. But because in the Wikipedia summary, this is being separated into 2 sentences, but when we retrieve the answer, we only look at the similarity between single sentence within the question, so they kind of lose the context which including in the previous sentence. And another thing we find is that some answer with high confidence, that is like over, for example, over 0.5 cosine similarity, a similar question that QBERT found in Wikipedia summary rather than the real answer. So for example, like here, QBERT is tricked by a sentence in Wikipedia say, why does the sun shine? So it's considered the answer of the why the sun is bright. So now I'm going to give a brief summary about what I've about my talk today. So actually, in this research, we designed like a new generalized model for question content analysis. And then we apply this model to this new with the curious open domain question corpus. So actually, there's one like a question left here is like, what did the corpus of question collected by with the curious review about the community that generated it? So this is kind of like was the last question that remained unanswered, but we hope that our analyze can provide a first insight of this corpus. So this is like not very surprising with the setting of the WTC is like a science institution. So we have like more questions related interesting in science, society and health. So yeah, although QBERT is like managing to answer like 43% of the question, there are still like some of the limitation with the QA models. So we can further, which leave us like a lot of space to further explore the QSS system, even also as well as improve the QBERT to a more generalized, question analyzing model. So that's it. So thanks for listening. So yeah.
Thank you very much for presentation. It's a very rich one. Does anyone have any question? Thank you, Gabor, for praising Ms. Chu's presentation. Anyone have any question? Thank you, Susan, for praising the presentation. If there is no question from floor, simply I want to ask some question like, for example, for your work, the main source of the content is Wikipedia.
Yeah.
And the content of Wikipedia is not static, it's somewhat dynamic. It's not very dynamic, it's somewhat dynamic. When you do the experiment, did you consider this factor and what kind of effect it's giving during the experimental?
So of course, like Wikipedia is like updated all the time. So when we do this research, so we only like use a specific version of specific dump from the Wikipedia. So it's from, I think it's from 2019. But this is like, so no matter like which dump you use, so we can still like use the same way to embed all the Wikipedias. And actually with our models, like the time we're actually using 7 GPUs to invent the whole Wikipedia summary. So it's like 22 million sentences. It takes like, I think it takes like around 16 hours to invent all of them. So even though like, so after once you invent them, then actually to retrieve the answer for, so you can always use this same group of inventing for searching, like no matter what question you are given. Then and once you're embedding them to perform the search for each question is like 0.2 seconds. So even though like, you know, Wikipedia keep updating, you can always use the latest version of the Wikipedia, you invent them and you perform the search. So yeah.
Yep, that's great. Thank you very much.
Okay.
Are there any questions? Thank you very much.
Thank you.
Best wishes for your future research. Let's move on to the